Page 341, 6-2, number 11. Solve the equation n divided by 7 plus, n divided by 10 plus 7 equals 10. This is similar to the decimal problem that I was talking about at the beginning of the class, except this time it's a fraction. And working with fractions in algebra, it's always easier if we don't have to deal with that fraction. So similarly to the decimal problem, there's a way for us to not have to deal with that fraction. And the way is to look for a common denominator. In this situation, we only have one of our terms that has a fraction in it. But if this one would have had something like 7/5, then we would have tried to find a common denominator for 10 and 5, which would have been 10. But in this case, there's only one of the terms that has a fractional part. So we can just look at this denominator and it's our chosen one. So what we're going to do is we're going to multiply every term by 10. And the reason we're going to do that is because if we multiply n divided by 10 times 10 over 1, the 10's cancel. And we're only left with n over 1. And n over 1 is the same as n. n divided by 1, whatever this number is, when I divide it by 1, I simply get that number. But if I multiply this by 10, I have to multiply everything by 10. So this ends up being 70, and this ends up being 100. So now I can simply solve this problem as a simpler algebra problem, being n plus 70 equals 100. So I am going to add the opposite here, and that means a negative 70. And when I do that, I get n, and this is 0, a plus 70 and a negative 70, sum to 0, and 100 plus a negative 70 gives me 30. So n is equal to 30. Now let's look and see if that works back up in the original equation. If I put n in for, or 30 in for n, I would have 30 divided by 10 plus 7 equals 10. And when I look at 30 divided by 10, I'm going to get 3 plus 7 equals 10. 10 equals 10. So my check works out. When n is 30, my original equation with the fraction does work out. Number 12. A group of friends went to the movies. In addition to their tickets, they bought a large bag of popcorn to share for $6.25. The total was $44.25. Total tells me that I'm going to be adding something. Was tells me where my equal sign is. So I know that I'm going to be adding something, and I know that when I finish adding, my total needs to be $44.25. Part A, write and solve an equation to find the cost of one movie ticket, and they want us to call that movie ticket M. They want us to use that variable. So I know right now that I am going to have my total cost is going to be $44.25. And so I'm going to be adding some things. And when I went to the movie, in addition to their tickets, I had to buy some tickets. They also bought a large bag of popcorn for $6.25. So $6.25 is one of my costs. That is my popcorn. And then each ticket is going to be a certain amount. And I bought 4 of them because there's 4 friends. So 4 friends times the cost of each ticket means 4 times m. So to solve this equation, because they want me to solve it, I'm going to be trying to get all of my m's on one side and all of my cost on the other. So I'm going to add the opposite of $6.25, so that's a negative, or you can think of it as subtracting $6.25, either way. And when I do that, I end up with 4m. This is 0 because of the additive inverse. And this is equal to, let's see, $38 on this side. So I have 4m is equal to $38. So since this is a multiplication, to undo the multiplication and get to where I just have 1m, I'm going to divide each side by the coefficient in front of the variable to get my m. 4 divided by 4 is 1, so I just have m left. And when I divide this, I'm going to get $9 and it looks like 50 cents. 4 times 9 is 36. I have a 2 left over, so that would be, nope, that's wrong. 20, so that goes in there 2 times. I better use a calculator. I'm not getting the right answer, I don't think. 38 divided by 4 equals, oh, it was $9.50. Okay. Oh, it's dividing by 4, not by 9. Oh, goodness. Okay, so the cost of each ticket is $9.50. Now, it says draw a model to represent this equation. So what they're wanting us to do is to use a bar model, meaning that we have an amount of money, and the amount of money is $44.25. And within this $44.25, we have some popcorn, $6.25. So this is the popcorn. And over here, these are the 4 tickets. So we have 1, 2, 3, 4. So here's a ticket, here's a ticket, here's a ticket, and here's a ticket. So when I add all of this together, I should get this quantity right here, $44.25. That's a drawing of this situation. Number 12. Oliver incorrectly solved the equation 2x plus 4 equals 10. He says the solution is x equals 7. What is the correct solution? So this one is just simply out there for us, and we get to solve it. There's no decimals, there's no fractions. It's just a straightforward 2-step process. So I want to get all of my x's on one side, so I'm going to add a -4 to each side, which is going to take me to 2x equals 6, and then 2x equals 6, This is a multiplication. To undo the multiplication, I do division. And I divide by the coefficient that's in front of the variable. So when I divide those, x is equal to 3. So let's see if that works in the equation. If x is 3, 2 times 3 is going to be 6, and 6 plus 4, does that equal 10? Well, by golly, it does. Okay, part B, what mistake might Oliver have made? He thought that the solution was 7. So I think what Oliver did was, instead of subtracting 4 here, I think he added 4. Because if he added 4 here, he would have gotten 14. And if he added the negative 4 over here correctly, that would take him to 2x. And then if you add 2x equals 14, each x would have equaled 7. So I think Oliver incorrectly added positive 4 instead of, now you can say subtracting 4, or you can say instead of adding negative 4. Okay, number 14. Use the equation 4 and 9/10 x minus 1 and 9/10 is equal to 27 and 5/10. What two properties of equality do you need to use to solve the equation? So let's just go ahead and solve it and see what we have. 4 and 9/10 x minus 1 and 9/10 is equal to 27 and 5/10. So the first thing I'm going to do is I'm going to change this to a plus and this to its opposite, which makes it negative. And because my x's are right here, I'm going to want to try to not have my negative 1 excuse me, negative 1 and 9/10 on the left. So I'm going to add the opposite of this, which is 1 and 9/10, and I'm going to add 1 and 9/10 over here. So the property of equality that I just used right here was the addition property of equality. Properties of equality just mean that we're doing the same thing on one side that we do on the other. So when I do that, these are going to zero out, and I'm going to be left with 4 and 9/10 x equal to, and let's see, I was adding there, so this is going to be 29 and 4/10. So now I have only multiplication left over here, not because of this x, but because the default operation when you have a variable and a coefficient means that this quantity is being multiplied by whatever the value of x will be. So when this is multiplication, to undo multiplication, I need to do division. And what I do to undo multiplication in this case is I'm going to divide by the coefficient in front of the x. And if I do it on one side, I have to do it on the other side. So the other property of equality that I just did was the division property of equality. Those little signs mean the same thing as what's above. So I'm going to divide and just get x down here, and when I divide right here, I should get something close to 6, because 29 and 4/10 I round to 30, 4 and 9/10 I round to 5. And I get exactly 6. How lucky for me. So when I put 6 back up in the original equation, and I can use my calculator for this, I have 4 9/10 times 6 plus a negative 1 9/10 equals 27 5/10. So I get the correct quantity on the right hand side. Okay. Number 15. At a party, the number of people who ate meatballs was 11 fewer than 1/3 of the total number of meatballs. Write and solve an equation to find the number of people at the party. Let X represent the number of people at the party. I just love it when they tell us what X is. That always works out very well. So, X is equal to the number of people at the party and they're telling us that the number of people who ate meatballs, so that's not the total number of people at the party, but the number of people who ate meatballs was, so that's my equals, 11 fewer than, there's that word fewer than, 1/3 of the total number of people at the party. So this means I'm going to take 11 and I'm going to put it to the back of the bus. And I'm going to be subtracting 11 from 1/3 of the total number of people. So I just said X was the total number of people at the party. And I'm told that 5 people ate meatballs. So the number of people who ate meatballs, well here, 5 people ate meatballs. So 5 must go right here because this is my was, and that indicates where I put my equal sign. So 5 is equal to 11 fewer than 1/3 of the total number of people. Remember that word of? That means multiply. What am I going to be multiplying 1/3 by? Whatever my number of people at the party is, and that is X. So I'm going to change this to a little dot. So here I have 1/3 times X minus 11. So 5 is equal to 1/3 X. And then I got to take 11 to the back of the bus equals 11. So as we said in class, order of operations generally says to deal with multiplication and division first and then do addition and subtraction. But we said in the class that when you're doing algebra, you always want to deal with your addition and subtraction first and then deal with your multiplication and division. So we're going to deal with this negative plus negative 11. In order to get this to 0, I'm going to add the opposite of negative 11. So that means 11. Negative 11 and positive 11 equals 0. So this is just 0. It's nothing. You can not even write it there. And then I have 1/3 X, but if I add 11 to this side, I have to add 11 to this side. So that's going to give me 16. 16 is going to be equal to 1/3 X. So just like in number 7 on the other page, when we have a fraction with a variable, that makes it rather challenging. And so to get this to 1x instead of being 1/3 x, I can multiply by the reciprocal. And if I take 3/1 times 1/3 x, my 3's are going to cancel. And I'm just going to have 1 times 1 on top and 1 times 1 on the bottom. So that's just going to leave me with 1x over here. And right here, I can take 16/1, bring my 16 down and multiply it by the reciprocal. Because if I multiply by the reciprocal here, I have to do it over here. So this is going to give me 48. So my answer is X represents the number of people at the party. So at the party, there were 48 people. Now, let's see if that works back in our equation. I'm going to have to move over here. 5 is equal to 1/3 of x, and I said x was equal to 48. And I'm multiplying those two things together, plus a -11. So 5 is equal to, let's cancel here. I know I can cancel there because when I add 4 plus 8, I get 12. And 3 is a factor of 12. So I know I can divide 3 into 48. That's going to give me 16. So 5 is equal to 16 plus -11, and that gives me 5 is equal to 5. So my problem checks out. Part B, write a one-step equation that has the same solution. Well, I think what they're looking for here is this one-step equation that has the same solution. I think this is kind of a silly question, but I can take this and I can get the solution of 48, because that's actually one of my steps here. So there are the solutions to your problems.